A large model Showman'S engine, and this one is part 22, testing the water lifter and fixing the dribbling bypass valve. In common with most traction engines of this type, this one has a water pump that's driven by the crankshaft. Here's the engine ticking over and the pump is in the foreground. The part that's wobbling at the right hand side is the reversing lever. I intend to tighten this up slightly. But the part I'm interested in is the water pump. The pipe at the top of it is a bit mangled and it has a tapered raincock type of water bypass valve. When the arm on the valve is vertical, the water is fed back to the tank, but in this position it means it's been pumped into the boiler. The valve isn't leaking too badly at the moment because there's not much compressed air in the boiler, but when the pressure in the boiler is high it leaks very badly. It has a really annoying, almost constant drip. Time I think to dismantle this part. I'm using 2 spanners, one on each nut at each end of it. When working with these type of valves, there's something you must never do. Never do this. Here I'm just illustrating a point. Do not put your spanner on the main centre part of the valve, because if you do and put pressure on it, then one problem you may have is you will distort the housing and the pump will leak even worse than it does already. When I dismantle this piping that takes the water from the pump and returns it to the tank via the valve, I soon noticed that the piping, which is 5/16 of an inch in diameter, is silver soldered into the unions at both ends. So the top pipe got even more mangled in the dismantling operation. This valve is called a taper plug cock. They are very common in steam applications and you can get them in many different sizes. This one's quite a large one. Take a look at the taper plug. You will see that it's not making contact with the hole all the way down. Instead, the contact is just at each end of the plug. I'm going to relap the plug into the tapered hole, and for this I'm going to use some T-cut to start with. The only thing is I'm mixing this T-cut with a small amount of grinding paste and a little WD-40 just to keep things moving. This is a very messy job. As you can see, my hands are getting very dirty as I try manually to lap in the taper plug to the tapered hole. To the naked eye this appears to be slightly better, but to find out if it still leaks I have to put it all back together. But before that I'll lap the part again using some Brasso metal polish this time, and eventually it looks like this, which on the surface looks good. Time now to bend a piece of 5/16 of an inch diameter pipe to make a new pipe for the top of the pump. I thought I would reuse the steam union, so I unsilver soldered that. And here's what's left of the original mangled pipe. Once I silver soldered the unions onto both ends of this piece of pipe, I deposited it in the acid bath for a while. And to answer a question I get asked very frequently, what type of acid do you use? Well, the answer to that is I use some stuff called Kilrock K, which is kettle descaler. You can buy it online, just Google Kilrock K. And as to the strength of the mixture, I originally used 10 bottles of Kilrock K, 400 ml size, to half a plastic dustbin full of water. The other end of the pipe from the valve goes down into the water tank directly, just using the pipe through the union nut. It's a no pressure connection, so you don't need to use an olive. I just fitted a silicone O-ring in the nut to keep the dirt out. Time now for reassembly, and as always I'm using some Loctite 542 to make sure there aren't any leaks on the joints. I fitted the valve back to the engine and the stupid thing is still leaking. I really do hate taper plug cocks. It's not leaking any worse than it did before, it's just that there's more air pressure in the boiler. There'll be a take 2 very shortly. In the meantime though, I'm going to test the water lifter. This is a great gadget. It's a special fitting that takes steam from the boiler and this pumps water into the bunker tank. Very simple and quite ingenious. Once upon a time when these traction engines were used on the road before they were taxed out of existence by the government, they would just stop by a pond, river or stream or possibly even a water trough. Place the water lifter pipe into the water supply and turn on the steam supply to the water lifter. Even on this large model traction engine, which is a third full size approximately, and currently running on my very small compressor which doesn't provide much pressure at all, it sucks the water out of this container with ease. and it really makes the lid on the filler rattle. This is one of the things that I like about machines of this period, when technology of this type ruled the world. I've removed the bypass valve once again, and this time I'm not taking the pipes off, because now I realise that this entire thing, including the pipes, is one unit and doesn't need to be dismantled into its component parts. I can see what the problem is. The plug is okay now, but the hole in the valve has some bad marks on it that come from the centre to the outside edges. This time I'm getting serious. I'm using some grinding paste, once again mixed with some tea cut to thin it out a bit, and the object now is to remove the marks in the hole. After lapping these parts together for a while by hand, I had a better idea. More tea cut required, and with the help of my battery powered drill running slowly, this seems to be a much better way to lap the taper plug into the hole. Luckily, on this taper plug cock there's quite a lot of metal on the outside edge, the larger diameter, so I carried on rotating this plug with the cutting compound until I'd removed every trace of the marks on the inside of the taper bore, after which I cleaned off every trace of the compound and got ready to put it back together. You have to be very careful if you do this on a very small plug cock because it doesn't work. You will remove far too much metal, and when you put the washer back on the end and the nut, then it won't seat at all. It was even impossible to tighten this up, so what I need to do is use a needle file and file the flat a bit deeper. This took quite a while, but eventually I started to make an impression, and the specially shaped washer went on perfectly. Eventually. The only trouble was that once I'd filed this flat, I still couldn't tighten the nut fully to hold the washer against the taper plug, and this is how the taper plug seals, by having positive pressure put on it and pulled into the hole. Over now to the lathe, and this is danger time. Even though I unscrewed and removed the handle, this part is far too fragile to machine when holding it by threads like this. Bear in mind it's only made of brass, which is quite a soft metal. You have a lot more control if you rotate the lathe very gently by hand. I'm using the thinnest parting tool that I have and removing very small amounts of metal at every rotation. But as you can see, slowly but surely, it reduces the diameter of the main shaft. And once I'd done this, the nut fitted perfectly and applied positive pressure to hold the taper plug into the hole. And now the leak is minimal. Not perfect, but minimal. The boiler's pumped up to 100 pounds per square inch, so I'm not too worried about this. And I think if I adjust the nut a little bit tighter and rotate the taper plug a few times, it could get even better. And here I'm doing just that. And almost immediately it starts to leak a bit more. I'm going to tighten the nut a tiny bit more. And as I do that, the amount of water escaping from the plug cock is a lot less. I rotated the handle a few times and then repeated the process, a tiny bit more on the nut. And I think this is going to make it just about as good as it gets. I don't really mind a slight dribble, to be perfectly honest, because at least it shows me that the valve is in the position where it's under pressure as the pump is being diverted to feed the boiler rather than return to the tank. Here's a clip showing the performance of the plug cock before the repair. A nice steady constant dribble. And now, after considerable effort, here's the aftershot. A bit of an improvement, I think. I'd just like to show you the water gauge. Look at this. And no, I have not filled the boiler with the blood of my victims from my acid bath. It's just the refraction of the light through the water gauge against the red light on the glass that makes it appear that the water is red, but it also makes it very easy to read the water level. The plug cock is working, not leaking at all, which is a good thing. And I've now reached the end of this episode. I just need to say, stay safe, stay well, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. and by doing that you can find other videos that you may like to watch, and by using the playlists you can actually watch the videos back to back, making it unnecessary to comment that the videos are too short.